For thousands of years, humanity has looked toward the night sky searching for answers. We have wondered how the first galaxies formed, how the universe transformed from a dark beginning into the vast cosmic structure we see today, and how far back in time we can truly see. Every generation of astronomers built more powerful telescopes, and each new instrument pushed the boundaries of discovery farther than before. But no matter how advanced those observatories became, there was always a final barrier. The earliest chapters of cosmic history remained hidden, waiting beyond our reach. The reason was not that those events had vanished. Their light was still traveling through space, carrying information from a universe billions of years younger than our own. But as the universe expanded, that ancient light stretched across unimaginable distances, shifting from visible wavelengths into infrared signals that previous generations of telescopes were not designed to detect. To witness the birth of the first galaxies and explore the universe's earliest moments, humanity needed a telescope unlike anything ever built before. The solution would become one of the most ambitious scientific projects in history, the James Webb Space Telescope. Designed to look deeper into the cosmos than any observatory before it, Webb was created to capture some of the oldest light in existence and reveal a universe that had remained hidden for billions of years. But achieving that dream required overcoming challenges that pushed engineering to its absolute limits. The telescope needed a mirror far larger than any rocket could carry, forcing engineers to create a revolutionary design that could unfold itself in space with extraordinary precision. Its delicate instruments had to operate in extreme cold, protected by a massive sun shield designed to block heat from multiple sources. And unlike previous space telescopes, Webb would travel far beyond the reach of astronauts, meaning every component had to work perfectly. There would be no repair mission, no second attempt, and no way to rescue the telescope if something went wrong. The journey of James Webb was not just a story about building a telescope. It was a story about humanity's desire to answer questions that had remained unanswered since the beginning of civilization. A mission that required decades of planning, thousands of scientists and engineers, and the courage to attempt something that had never been done before. This is the story of how the James Webb Space Telescope opened a new window into the universe, and how the discoveries hidden within its observations are changing the way we understand our cosmic origins. Chapter 1. The Gamble. Long before the James Webb Space Telescope transformed astronomy, scientists faced a frustrating reality. Every time they built a more powerful telescope, they could see farther into the universe, and, because light takes time to travel, farther back into the past. Yet no matter how advanced those observatories became, there was always a point beyond which they could not see. The earliest chapters of cosmic history remained hidden, not because they no longer existed, but because the oldest light had spent billions of years crossing an expanding universe. During that journey, its wavelengths stretched until visible light became infrared light, slipping beyond the reach of the instruments humanity had relied on for decades. If we wanted to witness the birth of the first galaxies, we would need a telescope designed for a completely different universe than the one our eyes can see. That realization gave birth to one of the most ambitious scientific projects ever attempted. Conceived as the successor to the Hubble Space Telescope, James Webb was never intended to replace its predecessor, but to continue the journey where Hubble had reached its limits. Instead of observing the universe primarily in visible light, Webb would specialize in infrared astronomy, allowing it to detect some of the oldest photons still traveling through space. In theory, this would let astronomers observe galaxies that formed only a few 100 million years after the Big Bang, bringing us closer than ever before to the moment when the cosmic darkness gave way to the first stars. Turning that vision into reality, however, proved far more difficult than anyone anticipated. Engineers quickly discovered that the telescope required a mirror much larger than any rocket could carry into space. The solution sounded almost impossible. The observatory would have to launch in a folded configuration and then unfold itself after reaching space with extraordinary precision. Its primary mirror was divided into 18 hexagonal segments coated with a microscopic layer of gold to maximize their sensitivity to infrared light, while beneath it sat a 5-layer sun shield roughly the size of a tennis court. That shield was not simply a protective cover. It was essential for survival, blocking heat from the sun, Earth, and Moon so effectively that Webb's scientific instruments could cool to temperatures of around 40 Kelvin, cold enough to detect unimaginably faint signals arriving from the distant universe. Unlike Hubble, which orbits close enough to Earth to be serviced by astronauts, Webb would operate nearly 1.5 million kilometers away at the Sun, Earth L2 Lagrange point. From there, it could maintain a stable orientation with its sun shield permanently facing the Sun, creating the cold and stable environment required for infrared observations. The location was ideal for science, but unforgiving for engineering. Once the telescope left Earth, there would be no repair missions, no replacement parts, and no second opportunity to fix a malfunction. Every deployment sequence, every motor, every cable, and every moving component had to function exactly as designed, because failure at any critical stage could end the mission before it ever opened its eye to the universe. The road to launch tested the patience of everyone involved. Years passed as engineers refined the design, solved unexpected technical challenges, and pushed materials far beyond anything previously used in a space observatory. Costs increased dramatically, schedules slipped, and criticism grew louder. Some questioned whether a single telescope was worth such an enormous investment, while others argued that the scientific rewards justified every delay. Despite the controversy, one fact remained unchanged. There was simply no other instrument capable of answering the questions Webb had been built to explore. Humanity could either accept the challenge or postpone those discoveries for another generation. When the Ariane 5 rocket finally lifted off from French Guiana on December 25, 2021, it carried far more than a telescope into space. It carried decades of scientific ambition, thousands of careers devoted to a single mission, and the hopes of a community determined to look farther back in time than ever before. The launch itself lasted only minutes, but the real test had only begun. Over the following weeks, Webb executed one of the most intricate deployment sequences ever attempted, gradually transforming from a compact payload into the largest and most powerful space telescope ever built. Against extraordinary odds, every critical milestone succeeded, and humanity found itself in possession of an observatory unlike anything that had come before it. Chapter 2. First Light. On July 12, 2022, after months of calibration and testing, the James Webb Space Telescope finally opened its eye to the universe. Scientists had spent decades imagining what they might see, but nothing prepared them for the moment the first images appeared on their screens. These were not simply sharper versions of photographs taken by older telescopes. They were glimpses into regions of the universe that humanity had never observed before, revealing details hidden behind clouds of dust and stretching farther back in time than any observatory in history. The first image released to the world was known as Webb's Deep Field, a seemingly tiny patch of sky no larger than a grain of sand held at arm's length. To the naked eye it appeared almost empty, yet Webb transformed that darkness into a landscape filled with thousands of galaxies. Some were so distant that their light had been traveling for more than 13 billion years before finally reaching the telescope's mirror. Many appeared distorted into graceful arcs, their shapes stretched by the gravity of massive galaxy clusters lying between them and Earth. Einstein had predicted this phenomenon more than a century earlier, but Webb revealed it with extraordinary clarity, allowing astronomers to peer even farther into the universe by using gravity itself as a natural cosmic lens. The discoveries continued as Webb turned its attention toward one of the most iconic regions in astronomy, the pillars of creation. Earlier telescopes had shown towering columns of gas and dust where new stars were believed to be forming, but much of that activity remained hidden behind thick clouds that visible light could not penetrate. Webb's infrared vision looked directly through the dust, exposing countless newborn stars still wrapped inside their natal cocoons. For the first time, Astronomers could observe these stellar nurseries with remarkable detail, watching the earliest stages of star formation unfold inside structures that had fascinated scientists and the public for decades. Another breathtaking target was the Carina Nebula, a vast region where some of the most massive stars in our galaxy are born. Webb revealed intricate walls of glowing gas sculpted by intense radiation pouring from nearby young stars, creating an extraordinary landscape that looked almost like towering cliffs illuminated by sunlight. Yet beneath its beauty lay an active laboratory of stellar evolution. Powerful winds and radiation were constantly reshaping the surrounding clouds, compressing some regions while eroding others, triggering the birth of new generations of stars, even as older ones transformed the environment around them. Webb also demonstrated that its greatest discoveries would not always come in the form of spectacular images. When astronomers observed the exoplanet WASP 96b, the telescope analyzed the starlight filtering through its atmosphere rather than photographing the planet itself. Within that faint signal, Webb identified clear evidence of water vapor along with clouds and atmospheric haze, showcasing its extraordinary ability to study the chemical composition of worlds orbiting distant stars. It marked the beginning of a new era in exoplanet research, one in which scientists could move beyond simply detecting planets and begin investigating the environments that surround them. Within months, it became increasingly clear that James Webb was not just producing beautiful images. It was delivering an entirely new level of scientific precision. Every observation contained an enormous amount of information waiting to be analyzed, from the ages of distant galaxies to the chemistry of planetary atmospheres and the processes shaping stellar nurseries across the cosmos. Around the world, research teams began examining the incoming data, expecting it to confirm decades of theoretical predictions while refining our understanding of the early universe. Instead, the data began asking questions that no one expected. The galaxies appeared older than they should have been. Some black holes seemed far more massive than current models could easily explain. And the earliest chapters of cosmic history no longer looked quite as simple as astronomers had imagined. The breathtaking images had captured the world's attention. But hidden behind every image was something even more remarkable: the numbers. And those numbers were about to challenge some of our deepest assumptions about how the universe evolved. As extraordinary as these discoveries are, they are only the beginning of James Webb's journey. Beyond these breathtaking images lie even greater mysteries: distant worlds, alien atmospheres, black holes, and galaxies from the dawn of time that continue to challenge everything we thought we knew. This is not the end of the story. Part 2 is coming soon, where we'll explore even more of James Webb's most astonishing discoveries and continue our journey deeper into the hidden universe. Until then, keep looking up, because the universe always has another secret waiting to be revealed. Thank you for watching.